example 10 asks us to solve the equation 3 to the 2x plus 1, excuse me, minus 18 equals 25 to the times 3 to the x. So what I want to ask you to see is that these examples vary from what we've done before in a couple of ways. First off, we're not dealing with only multiplication anymore, and that is a really key thing to understand. We have subtraction going on. We also have 2x and a single x going on. Anytime we have double an exponent and a regular exponent, what we're really dealing with is a quadratic equation. And it may not look like that at first, but we have to deal with that immediately. And we have to understand that because quadratic equations work differently. So what we're going to do is try to isolate this 2x and this x and try to create a quadratic equation. So our first step is going to be to realize that we have a plus 1 added on to this part where there's a 2x. So when we add an exponent by doing a plus 1, what we're actually doing is multiplying our base by another version of the base. So 3 to the 2x plus 1 is the same thing as 3 to the 2x times 3 to the first. And we're going to keep everything else the same. Now, this next rewrite I'm going to make, I'm going to move this 3 over just to make it look a certain way so that it makes it make more sense to you in a second. So I'm going to rewrite this as 3 times 3 to the 2x. I'm going to move this over, okay? I'm going to move this over to make this make more sense. 25 times 3 to the x minus 18 equals 0. Now, it doesn't look, but this is a quadratic. Now, if you look, this is 3 to the 2x. 2 times the exponent that 3 to the x has, which is infinitely times more than what we have as this constant here. What I'm going to ask you to make a stretch, and that stretch is that 3 to the x equals y. I want you to think of this 3 to the x as being some other number. So I can rewrite this in this way. When we decide to square something, we are doubling the exponent. This is the same thing as saying 3y squared minus 25y minus 18 equals 0. So the hard thing for people to realize is that if we square 3 to the x, we actually get 3 to the 2x. That's a hard thing for people to realize, but if you see this happen in any of these problems, you can understand that that's the same thing. Doubling an exponent is the same thing as squaring it. And so in these types of problems, we have to set it up to where we see this 2x and this x and this 18 to see that we have a quadratic equation. Now, keep this in mind. We have to go back to this later, but we're going to start with this point right here. So if we have 3y squared minus 25y minus 18, we now have a quadratic equation. So we're trying to solve for y. So we can try to factor. Doesn't always necessarily work, but we can do it. Let me think. So if I take away 9, okay, the negative 9 multiplies by the 3y to give me negative 27y, and then I add 2 back, times y, I get my negative 25. So this is the correct way to factor this, because again, my 2 times negative 9 is going to make negative 18. And so, I'm at this point right now. If I know that this is true, if I know that this is true, I know that 3y plus 2 equals 0, and I know that y minus 9 equals 0. Well, it's pretty easy to see from here that with my top equation, by manipulating a little, I'm going to subtract the 2 over and everything. I'm going to get y to equal negative 2/3. And I'm going to get y to equal 9 here. So from here, I have to realize that, I changed variables. So this is 3 to the x, not just y. So I'm going to say, okay, well, 3 to the x equals negative 2/3. And 3 to the x equals 9. Now I can take those traditional things that I've been working on before to heart. So, if I say 3 to the x equals negative 2/3, there's no solutions to this. I can't take a positive number to any power and make it negative. All an exponent does is multiply or divide. I can't multiply or divide 3 by anything to get a negative number, so there's no solutions. This one, however, I can work with, because again, 3 to the x, if I rewrite 9, I can rewrite it as 3 squared, right? And so I get x to equal 2. This is the only answer here. So the tough part with this problem, again, is realizing that we have to rewrite this as a quadratic. Take the example and take the information that they're telling you at the beginning to understand that this is how I'm going to have to do that. You're going to see this because we have subtraction or addition going on, and subtraction and addition make things far more complicated than they need to be. And that complication is that we have to think of this as a quadratic equation. Once we rename the variable, we can see that it's quadratic, and then once it's quadratic, we can solve for that variable and then reconvert and find our answer.